Okay, we are going to continue section 1.1. We just did degrees and know how to measure angles in degrees. Also, we learned how to convert from degrees to degrees, minutes, and seconds and back. Now we are going to learn another way to measure angles, which is called radians. Radians is a different way to measure angles. You remember, in degrees, we just take the circle and divide it into 360 equal parts. How are we going to deal with radians? Well, for radians, we are going to draw a unit circle. Unit circle, it's a circle of a size of 1 unit. I don't know, something like this. And my picture is going to be 1 square, 1 unit circle. The radius of this unit circle is 1 unit. Okay, so what are we going to do on this unit circle? Well, we kind of have a ruler to measure this 1 unit, right? I'm going to show you a ruler. Well, this ruler is not going to measure 1 unit as it is on my picture. Here, 1 unit is 1 centimeter, and in my picture, 1 unit is actually half centimeter. But imagine that 1 unit is half centimeter. Then what we can do? We can measure a length along the arc, which is equal to this 1 unit. In our case, it's going to be half centimeter. Well, my ruler is not bent, so I cannot precisely measure the length of 1 unit. But approximately, it's going to be something, you understand, something like over here. So 1 unit here, 1 unit here. What I'm going to do, I'm going to draw one more line through the origin and this point, which is 1 unit away on the unit circle. I'm going to get an angle actually, initial side, terminal side, and I'm going to call the measure of this angle 1 radian. And that's going to be definition of different unit to measure angles, radians. Well, that's kind of weird unit because actually you need a ruler to to see how many radians you have, right? We're going to develop an easier way and to count radians. We're going to start with seeing that the full circle is going to have how many radians? Well, let's see. Radian is going to be the length, right? 1 radian angle is 1 unit. Now, how many units are going to fit over here? To find it, we'll need to find the circumference of a circle. Everyone remembers, circumference of a circle is 2 pi r. In our case, because we use 1 unit, we are going to have 2 pi multiplied by 1 or just 2 pi. So the length of whole circle is going to be equal to 2 pi. You probably think, okay, pi is a strange number, right? But actually pi is not that strange. It's actually 3.14, 15, and so on, more numbers, but that's just a number. So it's approximately 3. So if you multiply by 2, you're going to get approximately 6. So length of the whole circle is about 6, a little bit more than 6. So it's going to be 6 radians. And that's how we measure angles in this alternative unit radians. Now, let's kind of make a relation between radians and the way we just learned degrees. So let's start with seeing that the full circle, which is like this, right, the full circle, in degrees, it's 360 degrees, right? And in radians, it's going to be 2 pi. We just learned that in radians, the length of the whole circle is 2 pi. Well, it's going to help us to find any parts of the full circle. For example, we remember that straight angle, which is something like this. The angle between two straight lines, or like open angle, is going to be half of this 360 or 180 degrees, right? 180 degrees is going to correspond to half of 2 pi. Half of 2 pi is going to be just pi, right? If we divide it by 2. Now, quarter, which was 90 degrees, remember? 90 degrees was the angle from here to here, all right? 90 degrees. What it was? Well, because 90 degrees is half of 180, it's supposed to be half of this too. Half of pi is pi over 2. What else? Well, let's write down 45 degrees. 45 degrees is a half of 90 degrees, right? So we're going to divide the pi over 2 one more time over 2, right? Which is going to give us pi over 4. Well, that's very good, but what if we cannot get the angle dividing 360 by 2? What if angle is something like 35 degrees? How do we convert it into radians? Let's see. Imagine that we have angle of 35 degrees. And we kind of don't know how many radians. We are going to put x radians. We do know that 360 degrees are making 2 pi radians, right? Now we can make a proportion that 35 related to 360, same way as x related to 2 pi, right? Because they are measuring, this is measuring this angle and this is measuring this angle. From this proportion, multiplying both sides by 2 pi, here 2 pi and here 2 pi, we're going to get that x equals 2 pi 35 over 360, which is approximately going to give us 0.61. In radians, everything is much smaller than in degrees, right? So now the question is how to go back, how to convert radians to degrees. Imagine, so that was, let's call it example 1, and let's make up example 2. Example 2, let's imagine somebody gives us 3 pi over 4 radians. It's not necessarily supposed to always connect it with pi. You can give just like 0.61 radians, which is just a normal number, and convert it into 2 degrees. But we are going to convert something with pi to make it easier for calculations. What is going to be the angle corresponding in degrees? Well, if this is in radians, then we are going to have x in degrees. I'm going to put measure of 360 degrees, and measure in radians is 2 pi for it, right? And make up a proportion again. So it's 3 pi over 4 divided over 2 pi is supposed to be equal x over 360. From where x, multiply both sides by 360, here cancel, here just multiply by 360, we are going to have 360 multiplied by what? Let's simplify this fraction a little bit. What we can do, we can cancel pi, for example, from top and bottom. What else? Well, we can kind of multiply this 4 and this 2. Remember that division by a fraction or by a number, it's a multiplication by inverse. Inverse of 2 is 1 over 2, and we're going to kind of multiply by 2 here. So it's going to give us 3 over 8. 3 over 8. And if we simplify it, we are going to have 135 degrees. So that's how we convert radians to degrees. Well, again, the same proportion, just like instead of unknown radians, we are going to have unknown degrees. Do we always have to put 360 here and 2 pi here? No, guys, if you wish, you can put 180 here and just 1 pi here. Remember that 180 is 1 pi. Still going to give you the same result, just less 2's and small numbers. Now, I want you to solve 2 problems on your own, and I'm going to count to 3, and I'm hoping that you can solve like both problems at the same time. So I will produce a solution after, okay? So solve problems. Problem A is convert 135 to radians. Well, we already know the answer, right? 135 in radians is 3 pi over 4. Can you get it actually using formulas? Question B, 11 pi over 6, a very strange angle. I want you to convert it in degrees. Okay, and I'm going to count to 3, and you can stop video and try these problems and then watch solutions. Okay, so 1, 2, 3. And let me do solutions. So for problem A, what we have? We have proportion 135 over 360 equals x radians over 2 pi radians. Remember, radians, radians, degrees, degrees. from where x equals, multiplying by 2 pi both sides, 2 pi 135 over 360. And we just multiply everything and get 3 pi over 4, which is exactly the same answer we have over here. Problem B. Well, I'm going to create proportion right away. So 11 pi over 6. How about using just pi instead of 360 and 2 pi? So I'm going to use pi here. I'm going to use x here, and over here I'm going to use 180. Well, again, that's your choice. You can use 2 pi and 360 or pi and 180. So from where x is going to be what? 11 pi over 6 divided over pi. I multiply by 180 on this side and 180 on this side. 180 and 180, right? Here it cancels, here it's going to stay, and that's going to give me 180. Now I'm going to cancel pi over here, nothing else to cancel, but I can divide 180 over 6, which is going to give me 30, right? And if I multiply it by 11, I'm going to have 30 multiplied by 11, which is going to give me 330 degrees. That's going to be my final answer. Okay, so we just learned how to convert degrees in radians and radians in degrees. Now, let's move to our next topic, which is called arc length. Arc length is very connected to radians measure because actually we are going to use radians to measure arc length. So arc length. Well, what is arc length? Imagine that we have a circle of arbitrary radius. And we are going to draw arc on this circle. Arc is just a part of a circle. I'm going to make it like darker. That's arc. So what we usually have, we have radius of a circle, we have angle of the arc, and we have length of the arc. If somebody measured how long is this anyway. Usually the question is, what is this arc length? What is S? Well, we are going to do proportion again, like we do with degrees and radians. What kind of proportion? Well, what arc length do we know for sure here? If you imagine that angle theta is not just this little angle, but the whole angle of 2 pi, we know the arc length which corresponds to it is going to be 2 pi r, right? So I'm going to write down that angle 2 pi is going to correspond to arc length of 2 pi r. Now, my little unknown angle theta is going to correspond to my unknown arc length f, and that's going to give me a proportion. So what I know here, I do know theta usually is going to be given, I do know r, and what I'll need to find is s. So multiplying both sides of this proportion by 2 pi r, we're going to have that s equals theta over 2 pi, this part of the proportion, multiplied by 2 pi r. 2 pi cancels, and we have a very simple formula, theta r. If you compare it to the formula for arc length for a whole circle, remember, circumference is 2 pi r, and here we have theta r. Well, it's very symbolic, right? The whole angle 2 pi gives you 2 pi r, but whatever part of it, if it's less than 2 pi, it's going to just give you angle by r. Very easy. Let's calculate something. Let's consider example. I think I'm going to change the page and use a different page to calculate, to do the example. So example, I don't know, example, I think that's going to be example number 5. Let's consider the arc with radius equals 10 meters. And theta equals pi over 2. And they're asking, question is, what is S? What is arc length? Well, I'm going to draw the picture. Picture is going to be a circle, not a very round one, but we're calculating this. The angle is pi over 2, right? And the radius is equal to 10 meters. You know that it's a quarter of a circle, right? Let's first get the answer just by guessing. guessing is take circumference, and we know that it's quarter, so measure a quarter of it, right? Circumference of a circle is going to be what? 2 pi r, which is 2 pi by 10, which is 20 pi, right? If we take a quarter of it, it's 1/4 of circumference is going to be 5 pi. So actually, you already have the answer. Now, let's get it using the formula. The formula tells us that arc length is going to be theta r. Theta, pi over 2, r, 10. Simplify, and again, same answer, 5 pi. So you see, common sense and our nice formula are giving us the same result. Question, what is going to happen if angle is given in degrees? For example, problem number 6, somebody gives theta as 45 degrees. And for example, they give us same radius. We just want to see like, okay, can they deal with degrees? And asking find arc length. Well, here we need to convert theta to radians. We do remember that 45 degrees is half of this like 90 degrees angle, right? Which is going to give us pi over 4. If you don't remember, you can use the formula and make up a proportion. Now what we do, we just substitute everything into formula. R theta, and our r is 10, and our theta is pi over 4. Well, we cannot cancel everything here, right? We just cancel 2 and 2 here, and we're going to have 5 pi over 2. If in the book they're asking you to give a decimal answer, you will need to take your calculator and multiply pi, which is 3.14, 15, and so on, by 5 and divide by 2. I'm not going to do this, but just if you want to check a decimal answer, you will need to do it. Okay? So, well, solve problem as usual. Solve problem is find arc length if the angle theta is 32 degrees and the radius is equal to 3. I don't know, centimeters. Let's call centimeters. I'm going to count to 3 and then give you solution. So 1, 2, 3. Well, because angle is given in degrees, first I have to convert degrees into radians, 32 degrees into radians. Formula works only for radians, just because it's created using radians. So I'm going to do it. So I'm writing down 32 degrees over 360 equals x radians over 2 pi, from where x equals 2 pi, multiplying 2 pi on both sides, 32 over 360. We can simplify it or we can keep it as it is. Now I know the angle in radians. I'm going to use my formula. S equals r theta. R equals 3, I'm copying 3 centimeters. And my theta equals now this complicated number, but calculator is not going to have any problems with this. Well, just take a calculator, multiply everything, and you can substitute pi over here like 3.14, and the approximate answer is going to be 1675, which is going to be in what units? Centimeters, because arc length or length is measured in same units, you have the radius. Okay, so we just learned how to deal with arc length. Last topic for today is area of a sector. Well, what is a sector and how to calculate its area? Well, imagine that you have a pizza and you cut a slice over this pizza like this. The shaded part is called sector, and there is a problem of finding area of a sector. So what is area of a sector? If you do know the radius of a circle and the angle which is describing this sector, you understand bigger angle is going to give you bigger area. Well, here we are going to make a proportion, but it's going to be slightly different because we're dealing with areas. Remember that area of a circle, the whole circle, is what? Pi r squared. Now, what we are going to do? We see that like a bigger angle over here is going to produce a bigger slice, right? A bigger slice means bigger area. And actually, you just can add up all the slices and get the whole circle. So I'm going to write a proportion looking like this. The whole angle 2 pi, the whole angle, is going to give me area equals pi r squared. Now, the angle theta is going to give me some unknown area. Well, I don't know, I'm going to call it just A. What do we know in this proportion? In this proportion, we do know the radius is going to be given, we do know the theta is going to be given, we don't know the area. So our goal is to find the area. What I'm thinking, I'm going to flip this proportion. Flip means that I'm going to multiply everything by area on both sides and multiply everything by pi r squared. So I have area 2 pi here equals pi r squared theta. Pi cancels on both sides, and area is going to be equal r squared theta over 2. Formula is slightly different from our previous one, and you do see that it's not that easy to remember, like area of a total circle is pi r squared, and here is theta r squared over 2. But if you recall that the whole circle is 2 pi, and this is kind of half of this angle. So what you see also half of the angle. So if you do remember this formula, it's very easy to get this one, just by analogy. This one corresponds to 2 pi angle, so pi is half of that. So here you just put half of the angle. Let's do example number 7 and just calculate something. Let's see. What example I calculated? Let's consider radius equals 10 meters and theta equals pi over 4. See what is going to be the area. Area is going to be 10 squared according to the formula, right? Multiplied by pi over 4 and divided over 2. I'm just going to plug in all the numbers. 100 instead of 10 squared and pi, and I'm going to move this 4 down and this 2 down. And I think my final answer is going to be, if I just plug everything in, it's like 100 over 8 multiplied by pi, and approximately equals 39.3. So I actually plugged in pi, which is 3.14. What are the units for 39.3? It's the same units you have for the radius. So we have meters, but area is going to be measured in meters square because radius is square here. So I'm going to put meters square. If you have radius in centimeters, it's going to be centimeters square. Well, our traditional self problem, and I'm going to count to 3. So angle is 225 theta. Radius, I think I'm going to give radius equals 2. And I want you to find the area. And I'm going to count 2, 3. 1, 2, 3. Solution. Well, first remember that we have to convert 225 and 2 degree into radians, right? 225 over 360 degrees. Unknown radians over 2 pi. It's going to give me x equals 2 pi. We multiply 2 pi on both sides. 225 over 360. It's going to give me what? Well, I multiply everything. I'm going to keep pi actually. I'm going to just multiply 2 by 225, get 450 and divide by 360, and I get 5 pi over 4. Now to calculate area, I'm going to use my formula r squared theta over 2. My radius is 2, so I'm going to put 2 squared. My theta is 5 pi over 4 and divided over 2. So what I have 4 here and 4 here cancel, right? And I have just 5 pi over 2. 5 pi over 2. If you want to know the decimal value, just plug pi into your calculator, multiply by 5, divide by 2. Well, here our units are same. I did not say what units are here. Let's put meters. We put meters here, then that's meters squared. Okay, that's all we're supposed to learn in this first section. And what you can do next, guys, you can take my little after lecture quiz. After lecture quiz is a very basic quiz. You don't need to do any homework for it and memorize any formulas. Just check your basic understanding of the lecture. And if you cannot answer certain questions of this after lecture quiz, try to watch lecture one more time, or maybe look at my notes, or try to read the book. Okay, so after lecture quiz is designed to give you idea, like did you understand the lecture or you have like parts of it missing. Okay, that's it. And that's end of section 1.1, and see you next week.